Okay, so in this section, we're doing volumes of revolution, but we're using cylindrical shells. So I just took this picture right straight from the textbook because it was probably one of the best pictures I had seen of this. We're going to be calculating the volume of a solid of revolution by using the method of cylindrical shells. And then we can look at different methods for calculating a volume of revolution. So here is a sheet of paper. A sheet of paper is actually rather thin. If I roll it and tape it together, then I can end up with a cylinder that looks as such. Okay, so now this cylinder does not have volume. This cylinder only has area, which is the area of this particular sheet of paper. But if you look at the picture, if I put a lot of these cylinders together and stack them up as if I were stacking them with soda cans on top of soda cans, then I end up with something that has depth or volume. Okay, so that is what we're looking at. And so when we do this, this is our sheet of paper here, okay? And so we're going to have some height. So this little piece over here, which is our delta X, is going to be how much it changes in X. And then this is 2 pi X. So that is the circumference of the circle that we're going to have here, okay? And then this is going to be the height. So we're going to get 2 pi times the radius. So xi is going to be our radius. And then this right here, 2 pi times the radius. This is the circumference of the circle. And then this distance, f of xij, that's just going to be our height. So therefore, the area of this particular thing is 2 pi times the radius times the height. Okay, so when we put them all together, we end up with a volume by shells. Now remember our original formula, as for all the ones that we have done: volume by slicing, volume by disc, volume by washer, and now volume by shells. All of them are to integrate through a particular area A of X. Okay, so the first one we're doing is a rotation about a vertical line. And so that's going to look like this. So if I draw a picture, let's draw a picture here. And then I'm going to have a function that's going to be coming from this picture. Okay, so here's my function. Let's say it looks like that. So this is my function, y is equal to f of x. And now what I want to do is I want to do like I'm doing before, but this is a little bit different. So here I'm going to be rotating about a vertical line. So I'm rotating like this. So I'm going in this direction. All right, so if I take a single line, and I rotate this thing about the x-axis, I'm going to have the y-axis, I'm going to have something over there, and you will see my cylindrical shell. So that right there that you're looking at is the cylindrical shell, okay? And then this thing may be going from up to some point from A to B, so it could be 0 to B, whatever. A to B. So here's my point A to B. And this is my X. So I can clearly see that this distance right here is X. So therefore the circumference of the circle is 2 pi times the radius, which in this case is X. And then the height. So this is the height. The height is h of X. That's the height. And so for us in this particular problem, the height is exactly just Y. So here's the height is exactly Y. So that is f of X. So you will see the formula look like this. And that is the most general formula. Okay, so this is the most general formula. Of course.
You said that, I have a question.
Yes.
You said that X was the distance between A and X.
No. I just said X is, X is the distance from it to the X axis, to the Y axis. So this distance is X.
Okay.
And so every time I pick a different X, so if I choose a different X here, then I'm going to get a different size shell. So this shell is going to be this big. All right. And so what you're doing is you're adding up all of the shells. When you add them up infinitely, many of them, you get an integral. So each shell has its own radius that corresponds to its X. So then you can get the circumference of the shell, which is just the length of this sheet of paper. So this takes one shell. Here's the radius as such. That's going to give me the circumference, which is this length, plus the height. That gives me the area. And then I integrate the area from whatever region of A to B that I have. Okay. So here, my R of X is just X, and my H of X is just Y, which is f of X. Now, of course, we're going to have some problems where R of X may not just be X, it may be something different. So we'll have to determine that. So that's the rotation about a vertical line. I can also do rotation about a horizontal line. So rotation about a horizontal line, if I have something that looks like this. So now I'm going to have a curve. And my curve may be like that. Let's say I take that curve. And this is now X is equal to G of Y. I'm now rotating it this way. So I'm rotating it about the X axis. So when I do that, I'm going to select the Y. So maybe I'm going from this region from here to there. I'm going to select the Y. And when I select my Y, I'm going to draw this cylinder. And notice if I do the same cylinder on the other side, that height, then when I draw my cylinder, there it is. That's my cylindrical shell. So I have a shell. And so now the radius of the shell, notice this time the radius of the shell is this height. So for this case, the radius is just Y. So that's why we get, here's the radius Y. Like back here, our radius was X. Okay. And our height is this distance. The height is here. Here's our height of the shell. It looks like that. That's the height of the shell. So H of Y in this case is just x, and that's g of y. And then I get that formula. Okay, so in general, if it's not a perfect problem, but in general, if I'm rotating about the x-axis, rotating about a vertical axis, so I have something like this, and I'm rotating about a vertical axis, then I get that the volume is the integral from A to B of 2 pi times my radius times my height. So I just need to find those things, and if I find them, okay, this is dx. But if I'm rotating about a horizontal axis or a horizontal line, so now I'm rotating like this, then my volume is the integral from C to D of 2 pi times my radius, which is going to be a function of y, times my height, and this is dy. Now, until you see a problem, this makes no sense. Okay, it's kind of like just words on a page. So what I want to do for you is give this some validity by solving some problems. Okay. So here's the first problem. It says the region bounded by the curve y equals the square root of x and the x-axis and the line x equals 4 is revolved around the y-axis to generate a solid. Find the volume of the solid. Okay, so the first thing I need to do, as we always do, is draw the region. Okay, Max, I can go back up a little bit. I don't know where you need me to go to, Max. Is that good, or do I need to go back further? Okay. All righty. Okay, so let's draw this region. And you have to pay attention to what it's saying. So I'm gonna draw my region. Y is equal to the square root of x. The x-axis, so that's down here. And the line x equals 4. So there is my region. Okay, so this is the region that we're talking about. And then I want to rotate it about the y-axis. So now, again, I'm going to choose a value of x. So I'm going to make a smaller x. Here's my value of x. And then I'm going to draw a line there. And then that same thing is going to happen over here because it's getting rotated about the y-axis. So when it gets rotated about the y-axis, there is my cylinder or my shell. So as you can see, that is my cylindrical shell right there. Okay, what is the radius of this cylindrical shell? Well, the radius of the cylindrical shell is that right there. And we already know that that's x. So here for this problem, r of x is x. Then we need the height of the shell. Well, the shell has this height. That's h. So for the value of X, the height is on the curve. So H of X is just going to be that height, which is Y. And for this problem is the square root of X. Okay, so that's what I needed. Now I need limits of integration. Well, they told me my region went from 0 to 4. So I have my limits of integration. And when this thing is done, it's going to look like a bread bowl. Oh, that's too high. Yeah. When this thing is done, it's going to look like a bread bowl. Okay, and the biggest radius of them all will be this red one that goes around like that. Okay, so it's going to look like a bread bowl. All right. So therefore, my volume is going to be the integral from A to B of 2 pi, my radius times my height, dx. So that's the integral from 0 to 4, 2 pi. My radius we said was x, and my height we said was the square root of x dx. Okay, so I can pull the 2 pi out. The integral from 0 to 4, that's x times x to the 1/2. So I get x to the 3/2 dx. When I get that, I have 2 pi. I'm going to add 1, so that's going to give me x to the 5/2. And I'm going to divide by 5/2, which means I'm going to multiply by 2/5. Evaluate that between 0 and 4. Okay. And this answer turns out to be 128 pi over 5. Okay, any questions about that?
I have a question.
Yes.
From x to 3/2 to 2/5, like, can you explain how you jump from that?
I can. All right, so now we remember that the integral of x to the n dx is x to the n plus 1 divided by n plus 1. So we get the integral of x to the 5/2 dx is going to be x, sorry, I'm already doing it, x to the 3/2. We're going to get 3/2 plus 1. That's what gave us the 5/2. And then we're going to divide by the 5/2. So when you divide by a fraction, you multiply by a reciprocal. And then this is x to the 5/2. So that is how I get this. Peyton, thank you for asking questions, because I know there are other people who are saying, I don't know how she did that. Okay, any questions? Okay. All right, so let's look at example 2. So example 2 says the region in the first quadrant, good, that lets me know where it is, bounded by the parabola, the y-axis, and the line y equals 1 is revolved around the line x equals 2 to generate a solid. Find the volume of the solid. Okay, so let's draw the picture. Okay. So this is the parabola y equals x squared, the y-axis, and the line y equals 1. So I'm going to draw the line y equals 1 first, just to get it over with. So here's y is equal to 1. Okay, and then I'm going to draw my parabola. So I know my parabola goes through the point 1, 1. So there's my parabola. Okay, and the y-axis. So here's my region. Okay, so that region, so here's what, this is x equals 1. So that region is revolved around the line x equals 2. Okay, so let's draw the line x equals 2. So x equals 2 is somewhere right about there. Good. And we're going to take this region and revolve it around that line. So again, we're still doing a vertical line. Okay, so it's still a vertical line. But when I revolve it, here is x equals 3. And then here's x equals 4. I don't want that black, I want it gray. Okay, so when I revolve it around the region, I end up with something that looks like this. Okay, so the region pops up over here again. So here's where the region pops up. Okay, and so for any value of x, now remember, x can only go between 0 and 1 because the region is only between 0 and 1. So for any value of x I choose, here's x. Then I need to draw a line like this. And I will draw the same line on the other side, and I will make my cylinder. So there is. So as you can see, there is my shell. Okay, so there's my shell. All right. So there are two things I need to find. I need to find the radius and I need to find the height. All right, so I already know the limits of integration. Why? Because this x can only go as far as 0 and up to 1. So that's my limits of integration. X can't be anywhere else but between 0 and 1. So I'll show you again. This x can only go all the way down to here and all the way up to 1. So the x value, I know that 0 less than or equal to x less than or equal to 1 gives me my limits of integration. Okay, so now I need to talk about the radius. All right, so let's find the radius. All right, I need the radius of the shell. So the radius of this shell is this distance. That's the radius of the shell. Can everybody see that? That's the radius. All right. Maybe bigger. Something bigger. There we go. That's the radius of the shell. Now we did this in another problem. Okay. We looked at how to figure out what that length is. Well, I know this is 2. Right here is 2. 1, 2, 3, and 4. Okay, so if I take this distance from Get rid of that arrow because I don't need it. So if I take the distance from 0 to 2, and then I have an X right here, and I want to find out how long this is, which is what I have in the pictures. Everybody see that? Here's my X. My X is right here. Here's my X. I'm going from 0 to X is this first piece, because this is where the line is. And then I have so if I take the whole thing from 0 to 2, that's this piece. And then X is here. So how long is the blue piece? How long is the blue piece?
Would it be 2 minus X?
It's 2 minus X. Okay, so this whole length is 2. I delete X, so this part is 2 minus X. This piece is X. Okay, so the radius I now know is 2 minus X. Okay, now let's look at the height. Height's kind of similar. If I'm trying to find the height, let me just draw this picture. So I know the top, this line up here is y is equal to 1. And then I know I have this parabola coming up like this. And that is y is equal to x squared. So I chose a value of x. And so now I need to figure out what this height is. Okay, so I need to figure out what that height is. Okay, we're going to do the same thing again. So let me draw a line. I know this is 1. I know this point is x squared. And I know this point is 0. So how long is this?
One minus X squared?
1 minus x squared. Okay, we're done. That's the setup. Okay, we're done. That's the setup. So now I can take 2 pi, so my volume is 2 pi, is the integral from a to b of 2 pi times my radius times my height. So that's the integral 0 to 1. Remember, x is trapped. X can only move within the region. So it's trapped between 0 and 1, 2 pi. My radius is 2 minus x. My h is 1 minus x squared dx. Now, in order to do that integral, you're going to have to FOIL that. Okay. And the answer turns out to be 13 pi over 6. Okay. Okay. Any questions?
Professor Lott.
Yes.
So like we were working on this morning, you said FOIL and then you would do the antiderivative?
Yes.
Okay. Just making sure.
Okay, so somebody is lost, and that is fine. Let me add some space and do a quick summary of this problem. Okay, so remember, I'm going to have some shell. Wherever the shell is, I'm going to have it. So wherever this shell occurs, so I don't know where the shell, wherever I draw my shell. So if I draw my shell look like this. Once I draw the shell and I see it, then I have to figure out its radius and I have to figure out its height, no matter where it is. Okay, so in the last problem, okay, so in the last problem, let's see, what's my picture? Great, it didn't give me anything, didn't carry anything over. Okay, so I don't need that. You can keep that, undo. You can keep that. Okay, so in the last problem, we drew our region. I'll make my picture a little bigger. Okay. So the region was here we had the line y equals 1. So I'm gonna draw y equals 1. Then we had the y equals the x at the y-axis and the parabola. So this was the parabola. All right, so this was my region. My region I always draw in yellow. And I want to revolve this region. Let's just say for a moment, I'm gonna make a new problem. So this is gonna be a new problem. Okay, so instead, we're going to revolve it about the line x equals 1. Okay, so just to be able to show the people that are confused the problem. All right, so here's x equals 1. X equals 1 is right here. Okay. And then I'm going to revolve it. So if I revolve it about x equals 1, I'm going to get something that looks like this. Okay. So what I do is I'm going to I need to find an x. And as I said, x can only go within that yellow region. So x is trapped between 0 and 1. Okay. So when I draw a line there, that line revolves around this axis. Oh my God, I only got through 2 problems. that line revolves around this, and when it revolves, you see the same thing happen, the same line happen on the other side. So when you revolve this point, it goes like this. And when you revolve this one, it goes like that. Okay, so the shape that it's going to be making, like it says, upside down kind of bread bowl. All right, so I need to find the radius. So the radius is this distance. All right, so I know that from here to here is 1, and here is x. So now my radius is going to be 1 minus x. It's going to be 1, because it's going to start from here. I'm going to take this whole thing, and then I'm going to subtract x. That gives me exactly that piece. So my radius is 1 minus x. Now I need to figure out what my height is. So my height is just this piece. Okay, well, if I go from here to here, that's 1. But if I subtract off this piece, what is that piece? Well, that piece is this height. This height right here is x squared. For any given x, that's x squared. So therefore, h of x is 1 minus x squared. So it's just a little different problem, okay? All right, I'm going to take roll while y'all do number 3. Actually, let's skip number 3. Ooh. That not easy problem. All right, I'll let y'all do number 3. It's the same region. All right, is revolved around the line x equals minus 1. So I took the same region as before. Hello. Hi. Okay, so here's my region. And I'm gonna revolve it around x equals minus 1. So this time, here's x equals minus 1 is right here. And then, let's see. So when I revolve it, I get something that looks like this. So my same region pops up on the other side. Here's x equals minus 1. Because this is x equals 0. Okay, so I'm going to select an x, draw my line. And then when I revolve it, I have the same line on the other side. And then I draw my shell. Now the height stays the same because the height's still this distance. So that's still 1 minus x squared. But what changes is the radius. So the radius changes. So now if you look at the radius, it's going to start from x. So here's x. So it's got this distance x, and then this distance of 1. So the radius is x plus 1. Okay, and then you compute it. So you get the volume, the integral from 0 to 1 of 2 pi. Your radius is x plus 1. Your height is still 1 minus x squared dx. And your answer turns out to be, I have no idea. Why didn't I compute the answer to that? Okay. This is 2 pi. The integral from 0 to 1, I'm going to have x, x plus 1, and then I'm going to have minus x cubed minus x squared. So that's going to be 2 pi, about 1 minute left. Stop. 2 pi, 1/2 x squared minus x minus 1/4 x cubed, 1/4 x to the 4th minus 1/3 x cubed. Evaluate between 0 and 1. So that's 2 pi times 1/2 minus 1 minus 1/4 minus 1/3. And they say something's wrong. Okay, now I got it. Okay. And then we just have to add the fractions. In the essence of time, I have 1/2 plus 1 minus 1/4 minus 1/3. So that's 11/12. 2 pi times 11/12, or 11 pi over 6. There we go. Okay. All righty, so tomorrow we may have time to possibly do one more of these. If not, I'll make sure Mr. Piaget does one on Wednesday. Okay, that's it for today.
Have a great day.
All right, you too.
Thank you.
Take care.
Thanks.
All right, Samuel. I'm gonna do the same.
Thank you.
thing. I'm gonna do the same thing, but you need to stay on because I got to introduce you. Okay. All right. I'm gonna go get me something and I'll be back.
You want to go somewhere with me?
Good afternoon, everyone. Samuel, I need to see your face. Hello, everyone. Good afternoon. Okay, so we have a new TA for the class, Mr. Samuel Piaget. So I'd like Samuel to introduce himself.
Yeah, hello everyone. So my name is Samuel Apiaje, and I'm a graduate student in DSU Math Department. I'll be TA for this course for the semester.
Okay. All right, so Samuel has TA'd for me before for Calculus 2. He's great at solving the problems. He will have office hours at different times than I have office hours, so you guys will have more than one person that you can come see if you need help. All right, any questions before we get started? Uh-oh. Error. I did that, made a mistake. Okay. All right, so I was actually in the wrong section. Okay, I'll fix it. Let me move this to section 2. I actually taught it okay, and then let me this, move that to section 1. Okay, so I had explicitly expressed that if you send me an email, you need to tell me what section you're in. If you don't tell me what section you're in, I'm not going to be able to address your concern. Okay, here we go. Uh-oh, where's my show? Oh, here it is. Let's share. Sam, well, I'm gonna do the same thing if you don't have to stay, if you don't want to.
All right, ma'am.
Okay. All righty. Okay, so let me start recording. Uh-oh, I already started recording? I'm confused.